Welcome back, Biomonsters. Today you're watching homework helper number 62, focusing on transport. We're going to focus on transport for this homework because you're going to see it again on your Term 2 assessment. So let's go ahead and dive in. For question number 1, it says, the movement of water into and out of a cell is called blank. The key word here is water. Anytime we see water moving, we always want to think of the term osmosis. And in our notes, we told you to turn the word osmosis into H2 and then O. And you can also turn that O into a water droplet to remind you that it's the movement of water. The other thing that you needed to know about osmosis is the second part of this statement. It says that this is a type of blank transport. Remember, things can either go from low to high, or they can go from high to low. Now, if things are going from high to low, it's like rolling a ball down a hill. So if this is my hill and I have my ball here, it's going to roll freely and it takes no energy. If water is moving into and out of a cell and it doesn't require any energy in order to do that, we're rolling the ball down the hill or we're going from high to low. This is a form of transport that does not use energy, and it's also known as passive transport. And there are 3 different types of passive transport that you'll be responsible for that we've already discussed. So you want to make sure that you go back and revisit that if you're not comfortable with it. Let's look at question number 2. Question number 2 says, circle the cells that are in equilibrium with their environment. The word equilibrium sounds like the word equal, which means that things are going to be the same on both sides. And remember, if given enough time and if things are permeable to a membrane, things always want to be equal on both sides. So here's your little hint that I gave you on your homework. When a cell's in equilibrium, the water, also known as the solvent, and the solute, the junk floating in the water, are equal. So all we're looking for is to see the same amount of stuff on the inside of the cell as we have on the outside of the cell. So when I look at this first picture, clearly there's not a lot of solute on the inside. In fact, there's none, and there's a bunch on the outside. So this doesn't work for me. It's not equal on both sides. If I look at the middle picture, I notice that I have 10% salt on the outside, 90% water on the outside for a total of 100. If I look on the inside, I see the same totals, which means that these two are equal to one another. So this works for me, so I'm going to go ahead and circle this middle picture. And let's make sure that we look at the last one to make sure that we're not leaving anything out. The last one, we have 5% salt on the inside, and remember, things always want to add up to 100%. So if it's 5% salt, we know that this is 95% H2O because together that makes 100. On the inside, we're at 20% salt, and again, that means that we're at 80% H2O because we have to add it up so it equals 100. And it's very clear that when we compare 5% salt to 20% salt, we know that the water values are also going to be different, so this also does not work for us in terms of this cell being in equilibrium with its surroundings. All right, let's jump down and look at question number 3. For question number 3, you're going to study each of the 3 pictures below, and again, it's a cell that's surrounded by another solution and your job is to tell me which way the water is going to go. And remember, things always like to go from high to low, right? Because we're not adding any energy. So again, we're going to look at this picture and we're going to note that we have a lot of solute out here. So if I have high solute, so this is going to be high solute, that means it's going to be low H2O because the more solute you have, the less H2O you have, because remember, everything has to add up to 100. If I look at the inside, this is definitely going to be high H2O, and I know that because there's no dots on the inside, so we have low, if any, solute present here. And because we want to go from high to low, so we need to make things equal here, if it's low on the outside and high on the inside for water, we know that water is definitely going to be leaving the cell. And if water leaves this cell, it's going to cause the cell to shrink. And another word for this is crenate. So those are 2 terms that mean the same thing. We're going to apply that same concept to the next picture. So again, we're looking at the amount of water and the amount of solute. And in this picture, they're the same. And we know that because it's the same thing from problem number 2. And if they're the same, we can say that this is an equilibrium. So water is going to be moving out and in at the same rate. So in this case, my cell's not going to get any bigger. It's also not going to get any smaller. So the cell will stay the same. And then looking at our last one, we have 95% water on the outside and 80% water on the inside. That means I'm high on the outside, low on the inside. And if things want to equal out, we have to move the stuff from the outside to the inside so that they become equal. So my arrow is going to be pointing in. And if my arrow is pointing in and water is moving into the cell, I know that the cell will have to expand. And if it continues to move in, there's a possibility that this cell can actually rupture, or another term for that is lyse. All right, now let's look at our next question. For our next one, we're taking these same concepts from our previous question and we're going to apply it to something that we actually know a lot about and we can see. So we're going to use a potato for this particular example. It says, if I put a piece of potato into distilled water, and notice that the distilled water is just pure water, meaning that there's nothing floating in it, there's no junk inside of it. What do you think will happen over time? Well, what I'm going to do is I'm going to say that this is going to be high H2O because there are no particulates or no solute floating around inside the water because it's pure. I know that a potato has water inside of it, but I know that it has a lot of other stuff. So that means H2O is going to be low. So I have low H2O inside. And we're going to follow the same principle that we followed before. Water always wants to be equal. So if it's high on the outside and low on the inside, the only way to equal it out is to move water in. So if that's the case, we're going to say that the potato will increase in size, or we can even say weight, because water will move into its cells. All right, let's look at our last one. It says, if I put a piece of potato into very salty water, what do you think will happen over time? Well, again, we're going to apply the same concept. If this is really salty water, that means that I have a high solute concentration and a low solvent concentration. That means that on my outside, I'm going to have low H2O. And because I have so much salt here relative to the amount of water, if I compare that relative concentration to the potato, it's going to appear as if the potato has high H2O. And if that's the case, we still want to be equal. If we're high on the inside, low on the outside, which way do you think water will move? Well, let's think about what we talked about before. We always want to be equal. And if I have a lot of stuff on one side and a little bit of stuff on the other, the only way to equal it out is to move stuff out from the high end and move it into the low end. So in this case, water is going to leave the potato. So the potato will decrease in size / weight because water will move out of its cells. All right, I hope that cleared up any confusion or misconceptions about this homework. Make sure that you understand it, and if you don't, after watching the homework helper and trying it on your own, be sure to stop by and see us because you're going to see these topics again tested next week on the Term 2 assessment. Thanks, guys.